All right, I'm going to talk a little bit about the binomial distribution. So, in a binomial distribution, we're thinking about an experiment that has n independent and identical trials. Each trial ends in success or failure, and the probability of success is p, and that's the same for all of the trials since they are identical. So, examples of a situation where you might use this would be coin flip, it lands either heads or tails. Say heads is the success. Test question, it could be answered correctly or incorrectly. Correctly would be success. Or in a more business-like setting, maybe you have a client that signs a contract or doesn't sign a contract. Signing the contract is success. Or you could have other examples. Maybe you've got a product and it's defective or not defective. Maybe defective is success in this quality control setting if you're wanting to identify bad objects. But whatever the case is, that's the basic setup for this. So with this, the key formulas, the expected value is just the number of trials, n, times the probability of success, so n times p. The standard deviation is a little bit more involved, so it's that n times p, then multiplied by 1 minus p, and then that entire expression, you take the square root of it. So that gives you the standard deviation. So if you had some numbers, if you knew what the number of trials where it was, so n, you know what the probability of success is, you can just plug into those formulas to get out the mean or the standard deviation. Now, if we're thinking about what's the probability of getting a particular number of successes, so you contact 10 clients, what's the probability that 5 of them sign a contract? You flip a coin 10 times, what's the probability that it comes up heads exactly 4 times, or something like this? We have a formula to use. It's shown there on the screen, but it's very unlikely that you would end up in a situation where you're actually plugging into that formula. Excel can calculate it for you. But here you're going to be able to get out the probability of certain outcomes, right? A certain number of successes. So an example here then is you've got a sales representative. The rep contacts 20 clients in the week. Each client has a probability of 0.4 of signing a new contract. So we're curious, how many new contracts would we expect to see? And the answer is 8, given the formula. What's the standard deviation for the number of successes? The answer is 2.19. Again, just applying the formula. So plug in, work it through. And then the probability of getting exactly 8 successes, which would be a contract that gets signed, plug into the formula, which again, unlikely to do, but if you want to just practice with it at some point, you can punch that into a calculator, but it would come out to be 0.1797. But also there might be very few cases where you're interested in getting exactly 8 successes, so look at a way to get 8 or fewer, something like that. So again, unlikely to punch this into a calculator or try to really work this out by hand, because in Excel you can find this probability by just using the binom.dist function. And the arguments that takes are the x value, the number of successes that you are looking for or asking for the probability of getting that, n, the number of trials, p, the probability of success, and then use the option false if you're wanting to get exactly that number of successes. Change the false to true if you're looking for getting that number of successes or fewer. So instead of asking about getting exactly 8, you wanted 0 through 8, then that option would become true. So let's just look in Excel with a couple of examples. Let's use the 20 clients and the 8 successes that I mentioned before. And then we can also think of an example where you're flipping a coin and the probability of getting heads. So we'll change the probability to 0.5, and the probability look at the probability of getting a certain number of heads. So let's just go to Excel, and if I look here, I go binom dot dot dist, and then what am I going to put in? the number of successes that I'm looking for. We had an example with 8. How many trials were there? 20. Probability of success, 0.4. Let's go ahead and go with false. First go. It gives us the 0.1797. Now, if I make one change here, I'm just going to copy that into the next cell. I'm going to switch the false to true. Now it's going to give me the probability of getting 0, 1, 2, 3, 4, 5, 6, 7, or 8. So that's going to be larger than 0.1797. And indeed, it comes out to be larger. Give a different example. Again, binom.dist. And let's consider here, you've got maybe a coin that you're flipping. You want to know what's the probability that it comes up heads 5 times. You flip it 15 times. Probability of success is 0.5. You want to know the probability it comes up exactly 5 times on heads. So you would type this in, and it gives you 0.091644287 as the answer. And so that's how you can use Excel to answer questions about probabilities relating to the binomial distribution.